Okay, so this is what I'm going to talk about today, just some reasons I've come up with to start using Microkit, my own experience learning how to use Microkit, how DonorWorks and other companies can develop real-world products on Microkit, and how DonorWorks can get involved. A little bit of background on the issue, DonorWorks already has a tremendous amount of experience working with CAmkES VMM technology already. We've done just a lot of work for customers in the aerospace and defense areas, including for NASA, Collins Aerospace, US Army, a bunch of others. And so I tested Microkit on just like a couple simple virtual machine configurations just to see how it works and how I can, how it's compared to CAmkES. And I tested this on the Xilinx ZCU102 board, which it was not, when I did my testing on this back in March, it was not a fully supported board yet, but it is very close now. And so using that, I was able to kind of compare the Microkit VMM to the CAmkES VMM in an objective way. So why use Microkit VMM? So first, from a technical perspective, is its tight integration with the SEL4 device driver framework. And this is, as you've seen before, just a framework to write device drivers. I think that it also has an easier development process, and it's a lot less intimidating than CAmkES is, mainly because the abstractions that do exist are simpler in nature and fewer in number. This can definitely help lower the barrier to entry to new engineers. Another thing is we want to stay up to date with the latest advancements from the SEL4 Foundation, and this is definitely cutting-edge technology. And you can write applications in non-C languages already, like Rust, MicroPython, and Zig have been used successfully. From a business perspective, I think that Microkit could have just a much quicker onboarding time than CAmkES, and this is a big plus for our customers and new engineers to be able to pick up and actually use this technology. Finally, I think that DonorWorks can provide just a unique experience perspective for Microkit as a business use case. We have we're very industry and customer focused. Skip this one. Some things that I like when I was using Microkit. First of all, is it's simpler environment. Easier to set up the environment to use. There's way fewer dependencies that you would, if you want to install the CAmkES versus Microkit dependencies on the host. In the tutorial, Microkit tutorial, I believe that there were 2 dependencies, one of which was QEMU, which you don't necessarily have to do unless you're simulating something. It's also installed as an SDK versus with CAmkES. You have to manage like over a dozen different separate Git repositories. And so if you want to make just like one small change, so usually you have to go in, you have to edit multiple different repositories, submit a couple of different merge requests, and then it just seems like stuff gets messy and it can be a little bit convoluted. I definitely like this better where if you have a project, everything is just in the single Git repository. Another one is, like I said before, easier to grasp abstract concepts, and a very friendly user manual. I really liked it. It was easy to learn from. Another thing that I noticed is the system reporting feature. That's what I'm calling it right now. This is the report.txt file that gets generated with every Microkit project. And it's basically a snapshot of a running system, which describes which entities have access to which SEL4 capabilities. And it lists the physical addresses of guest RAM and ELF file regions, and just kind of documents that there's no overlap in guest memory, like between separate VMs. And this helps to prove out our system isolation claims to our customers, and it's extra proof of that. My learning experience, first thing, when I was using the ZCU102, and this is true, I looked back for like all Xilinx boards, which would be the ZincMP and Versal. It tripped me up at first, but you need to make a change to U-boot, recompile it, and then put it back onto the board, specifically because for the Xilinx boards, if you're using the go command to execute and boot an image, the current U-boot code, the default behavior is to drop the exception level from EL2 to EL1, and this is not going to work with Microkit. It has to boot at EL2, of course, if it's using a hypervisor. So just a small change must be made to the boot source code to work with Microkit. And to clarify, this extra step is not needed for CAmkES. So you can configure the output image to be a ELF file and just boot it with boot ELF on U-boot. Another thing, as I was going through it and learning it, is that I think that Microkit can require a bit more manual configuration than CAmkES VMM. So yes, like everyone says, CAmkES can have a steeper learning curve, but like a lot more code to me seems to be generated because it's got a build system, and most of the configuration is done using attributes and the settings files. So once you kind of get to know what's going on and like how all the different buttons and knobs work, I feel like I have a menu of options to choose from and a starting place, and it's just easier to create designs from scratch. Whereas Microkit, it can be a little bit more cumbersome, but I'll talk about that and some other solutions a little bit later. So for developing real-world products using Microkit, I assessed Microkit's readiness level for this task using a 28-point test, which analyzed, among other things, the type of supported platforms it has, ability to pass through devices, CPU pinning capabilities, single and multiple virtual machine configurations, architecture support, and others. So Microkit can do almost basically everything we need it to right now, but there were two things that I highlighted that we really need that are very important to our business at DornaWorks. First is x86 support. At DornaWorks, we're seeing a growth of demand for SCL4 on x86. And DornaWorks has been supporting a lot of this growth on the SCL4 mainline repositories. Our customers really desire this architecture because it has a high compatibility with modern and legacy software. And x86 definitely is used in more high-end computing platforms, less embedded, where this is just where Intel's always had a large market share. I know ARM is starting to break into this market, but Intel is still really the king here. The other thing was having multiple vCPU instances per virtual machine instance. And this is especially useful to DornaWorks use case, as we use SCL4 with hypervisor support enabled exclusively. And we just need to make full use of all the cores that platform has for Linux to be able to run on top of SCL4. Can't go back and tell our customers that, okay, you want to run this, we can only run Linux using a single core. And so I've talked to other project managers at DornaWorks, other engineers, and we just won't be able to transition without this. This is very important. I did also review the roadmap a couple months ago. I saw that both of these things were requested, and in Ivan's presentation very recently, you talked about x86 support, but I thought it was fair to highlight it again because these are just so important to our business. So when I was talking about before that Microkit can require a little bit more manual configuration than CAmkES, this is one possible mitigation or solution is DornaWorks tool VM Composer. And this is basically a GUI that allows you to create a VM or a hypervisor system from scratch using drag and drop components. It's similar again to what Ivan talked about with his GUI program, but this one is a little bit more high level in that it's also for hypervisors, and we have great platform support for certain boards like the ZC102. We've got that one locked down. So here's just one example with how Microkit can require more manual configuration. Say you want to pass through a UART device. This is really common. With Microkit, you got to add in all the different memory regions. So you got to go back to the device tree source. Okay, so then what's the path that I got to add in? What's the IRQ? Then you got to map that back into the protection domain, and you also have to add that to your VM source. So it just becomes a little bit more cumbersome. Versus with CAmkES, you can just add the path to the DTB attribute, and especially if it's if you're using CAmkES with a board that's already been ported to SCL4/CAmkES, you have the hardware abstraction for that your devices take advantage of. So developers will likely start working with a known working example, modify it from there. So that's where our product comes in. It can generate all the code needed for a complete project and just builds a bootable image. So my thought is, this is already working for CAmkES. How about we extend this also to Microkit? It's not done yet, but this is an idea for the future. So here's an example of how it works with Microkit. So this is like really common, having a serial server. You need, for your VMs, they have to be connected to a serial server to get serial I/O, so you can actually see what's going on. So you can, with this, drag, drop, plop down a serial server protection domain. Here's all the code that it could generate. And again, it's a theoretical example. And then you can attach in a UART device. Wow, there's the code for it, including the, you don't have to go into the device tree to look for the path, and it adds it also into here. And also, you don't have to flip back to the source files like the vmm.c file to add that the IRQ in. And you can connect it, you can create a channel to connect it with another client or another virtual machine. And then it'll create the client IDs, and you don't need to add them back into the VM source. So using this tool, especially this is how I kind of really got the hang of CAmkES. It was just really helpful to learn how a project was generated. And so this is really going to be helpful with just simplifying, copying and pasting some boilerplate code. And it can just ease some of Microkit's inconveniences, some pain points. I talked to some other engineers. They said this was one thing that it just seemed a little bit weird that you had to just flip back and forth to all these different spots, especially because Microkit doesn't have a build system. So I've talked to other DonorWorks engineers. They're all really excited to try Microkit, see how it's different from CAmkES. We are planning right now to add Microkit support to VM Composer, but there are still some features that are needed to make an effective business use case to our customers. So what are people's questions on this?
Ask the question to ask the questions.
Yeah. So is it true that most of the kind of drawbacks of Microkit can be hidden behind the VM Composer? And so when you're actually building the system, it kind of looks the same whether you're doing for Microkit or CAmkES?
I mean, yeah, we can generate, if we implement Microkit into VM Composer, we can generate the code for Microkit we should be able to just as easily as for CAmkES. Does that answer your question?
Yeah, is there any kind of thing that's left that Microkit still needs to provide if you can hide everything behind VM Composer?
I mean, there's still some stuff that I'm sure that you, really our VM Composer when we introduce that to customers, it's, if you want more of a simple, hypervisor system or VM virtual machine system where, just a couple of virtual machines and some virtual I/O, but it's not a super complicated system. Then you'd have to come to DonorWorks and actually, pay us for a more complicated system. Yes, sure.
Yeah, I think also the biggest thing that we have a lot of features in with VM Composer is support for multi-core and SMP. So needing multi-kernel support to get to that, to maintain feature compatibility is what we're really missing. But once we do have that, I think tooling like VM Composer and others can really also help with the issues you have with the multi-kernel approach, which is making sure at build time you have isolation between the resources that are given to each kernel, right?
How much would VM Composer benefit from what's already there in the composition tool Ivan talked about?
yeah, that could definitely be helpful. I was talking with Nate and Robbie about. I think that could definitely be really helpful. I was talking with Nate and Robbie about that before the break. We saw that Yvonne added that, or that he introduced that, his GUI program. And I think that would be cool to like maybe collaborate and just get like a little bit more fine-grained control in VM Composer. There's some just other things that could be added to it versus just like, okay, plop down your virtual machines and here's are your connections and here's your devices.